Hello students. Today I'm going to discuss with you about the another very important aspect in greenhouse construction. It is about the foundations of the structure, on which is is the main component of a erected structure, because the strength on foundation is very important, as the whole structure durability and stability depends on this foundations. And then we will be discussing little about the cladding material and what about the different qualities of cladding material. So this is a typical naturally ventilated structure, and you can just see the diagram here. The whole frames are, like there are different frames. You can just see here: one, two, three, four, 5, 6, 7, 8, and 9. These are 9 frames of GI pipes, and these are been, prefabricated, and they are not bolted on the side, and then they are, joined with each other with the help of another support pipes, and they are given strength with another pipes. And then once the full frame of structure is ready, the sheet is installed on it. But this all structure is is tied on the foundations, which are been grouted here around 3 feet depth, in 3 feet depth, and then they are cured for that. So this is on this. Now the foundations are generally of two type. One is the traditional foundation, and another is the telescopic foundations. Now this is very important. You must understand this thing, that in the traditional foundation, as you know, that in the construction works, normally a pit is dug, and with the concrete combination of cementing material and the you know concretes, the mixture in the ratio of 1 is to 6, 1 is to 6 is to 3, or 1 is to 1 is to 9, or like that. As the civil people knows, this material is, the pipes are grouted, and then the structure is erected. This is the traditional structures, but in telescopic foundations there is a little difference here. Here we have, the foundation pipes are made separately, and these are not the long pipes of GI, but they are around, only the foundation pipes around 3.5 feet in length, out of which 3 feet is buried in the ground, and only the tip of it is remained open in the fields. And once these foundations are cured, then on this foundation uh, the structure pipes are installed, and they are put to the nut and bolting. I'm just trying to explain this thing here with the help of pen. Now generally what happens, a pit is dug like this, and a foundation pipe is added in, fixed in this, like this may be 3.5 feet, and all this is filled with concrete here, and this is, or being RCC'd here, and this concrete material is filled in this, and it is cured. Now this pipe, which is present here like this is the pipe. This is the foundation pipe erected, present outside. Now with the help, the another pipe which we will be, on which the structure is made, so this pipe will be a little bigger in dia, and this pipe will be, kept on this, like this, and this is nut bolted here. Now what happens whenever, and then the structure is made on this. Now whereas in traditional foundation it is as simple as this, that the long pipes which are present, they are simply, back kept on this, and then the structure is made on this. Now what happens when there is a wind or thunderstorms comes, or very shaky, the whole structure is shaking. So in this case there is a breakdown here. Sometimes the structure get broken from here, and this whole structure falls down. Whereas in this type of structure, there is a movement here, as there is space here, So this is the above pipe can move on this particular the down pipe, and then the structure become little shaky, and then it is it can withstand wind better, and there is no breakage of the pipe with winds here. And then so the telescopic foundations, they are considered the better option for erecting the polyhouses. Uh, More clearly in this picture, it is clear that in traditional method, straightway the structure is made and the column is erected on the structure. This is the ground level here. This is the ground level, and the material is dug in, and RCC is added, and the column is erected. Whereas in this case, this is the pipe which I am just trying to show you, and there is another pipe which is little bigger in dia here, and it is this structure erected on kept on the structure and fixed on the structure, and as such it is can shake on them the foundation pipe. Now this in this case, the pit below ground level, easy method, cheap method, less time required and accurate. And then these foundations can be in an open space, can be properly the foundations are fixed, and then on the foundations the structure is erected. Now the structure erection is done with on these telescopic foundations. Once they are cured, the main columns, side columns, arches, purlins, gutters, which I have just showed you in the picture, as per the layout, they are nut bolted, and the structure is erected. Now, once the structure is erected, then the next step is about the fixing of the sheet or the polythene. So there is a zigzags. This is like a zig, and aluminum profiles. This is a profile sample. This is called the aluminum or GI profile, and this on this with the help of a zigzag wire. Which is present, the polythene is fixed on the structure. So now the next very important part of a poly house, or you can say the very important part of the poly house, is the polythene. So this is the poly sheet which is we use to cover up the structure, and this is called the cladding material, or you can say the cladding material for poly houses. Normally, what are the different qualities of this sheet are given here. So this is a very important from exam point of view also. There's so many times the question being asked that how what are the different qualities of a poly sheet which we are going to use. So this is transmission is around 88%. It is strength, is thermicity, diffused films, and then the thickness is very important. That thickness is around 200 micron. Normal lifespan is 2 to 3 year. These sheets are UV absorbent and resistant in UV, and there is a anti-dust and anti-fogging. These are two important aspects of this. Now I will explain them one by one. The anti-dust means that the dust or is not settled on these sheets, and it is not they are not the sheet is not sticky enough that it can hold the dust from outside environment. Thus anti-fogging is like when there is a transpiration is happening inside the greenhouses, so there is lots of humidity being generated, and this water is get struck to the top layer, just like I'm just trying to make it to understand you here. For example, this is a poly house. uh, Now what happens when there is a plant here? For example, here is a plant. Now what happens when it is transpiring, the water vapors are going like this to the top, and here it condenses, and then they drop like water drop. Then there is a drop like water drop here, down there, like this, and then this may fall on this plant also and cause damage to the plant. But in these kind of sheets, which is anti-drip or you can say anti-fog, what happens? The vapors which get condensed, they are not going. falling directly to the soil, but they remains adhere to the sheet, and they with this sheet they are just falling on the ground from the sides like this. So once they are falling like this, so there is no direct droplets may be falling on the plants, and as such, there is a naturally they are saving it from the heavy drops of heavy velocity which may be falling and may drop may break some plants or birds and all. So this is the anti-fog. Then there is some sheets are having other qualities also, like anti-algae or anti-petal blackening and all that. But normally we go for 3A sheets, which is anti-dust, anti-drip, and ultraviolet. Now, after the poly sheets, the next very important part is the shade nets. Now, in just like your poly houses, the shade net houses are also playing a very important role. Whenever you have the primary and secondary hardening of tissue culture plants is concerned, so this is always happening in these kind of shade net houses. So there are different type of shade nets available depending on the light whatever that they have, how much thickness is there. Depending on that, these different nets has 40%, 60%, 80%, 90%, their nets are available, how much they light they can pass on, and then on the basis of the requirement they are selected. Generally green nets are used, which is called the green net houses, and they just give the filtered light and shady environment to the plants, and the plants which are just coming from the lab or are sensitive enough, they can survive well in these kind of net houses. There is some aluminum nets also. The white nets are also they are also acts as a thermicity. They have a thermicity and they increase the temperature also, and sometimes they are auto driven. So they also heat the poly house by absorbing the heat from the sun. Generally, these sheets are cleaned from the outside with the some soapy material and all that. So this is the maintenance angle. Then there is a structure. We know that they have woody poly house, shade houses, and polytunnels and all. They are the different low cost structures. So this is about the today's topic, which is about the discussion about the foundations and especially and the cladding materials. Thank you very much.